So the intersection control evaluation is a data-driven, performance-based framework and approach used to objectively screen alternatives and identify an optimal geometric and control solution for an intersection. The process allows us an opportunity for safety to be integrated into the intersection control decisions, leading to the implementation of safer, more balanced, and cost-effective solutions. The goal of the evaluation is to objectively select a control strategy that meets the project's purpose and need and fits the intersection's location, context, and roadway classification while achieving the overall long-term best value. So a little bit of the evolution of the intersection control evaluation process. In September of 2015, NCHRP completed the report estimating the life cycle cost of intersection designs. In December of 2017, MassDOT started a task with Kittleson to develop MassDOT intersection control evaluation procedures. In 2019, 10 states had an intersection control evaluation policy in place. In March of 2021, MassDOT released the Engineering Directive E21002, which had the pre-25% design scoping procedure, which included the intersection control evaluation. By 2022, 15 states had an intersection control evaluation policy in place, including Massachusetts. And then in February of 24, NCHRP Research Report 1087, the Guide for Intersection Control Evaluation, was released. As I noted, the MassDOT Engineering Directive, which included the intersection control evaluation, was released in March 2021. The new procedure was noted at the pre-PRC meetings in PRC Project Review Committee, for those who are not familiar. Intersection control evaluation was presented at the Innovation Conference in May of that year, and the Safety Alternatives Analysis Guide was published in October. In 2022, the Intersection Control Evaluation and Safety Alternatives Analysis was presented at the Mass ITE annual meeting, and the first intersection control evaluation submissions started rolling in, including 8 Stage 1 submissions, 1 Stage 2 submission, and 1 Stage 3 submission. In 2023, MassDOT started making some improvements to the procedure. We piloted an on-call for Stage 1 submissions, which helped designers get paid for doing Stage 1, allowed for scopes and fees to be developed with fewer unknowns, and for the scoping meeting to be used as a comment resolution meeting for Stage 1. We developed an applicability form that was rolled into the MAPIT project intake tool process, which allowed us to easily determine where the evaluation was needed for projects. We updated some portions of the procedure and began developing training videos with Kittleson to guide designers in the process. In 2023, the number of submissions grew significantly, with a total of 80 Stage 1 submissions received, 38 Stage 2 submissions received, and 1 Stage 3 submission received. In 2024, we continued working with Kittleson to finish the training videos and updated more of the procedure and developed an abbreviated ICE Stage 2 process. Traffic and safety staff presented this information to project managers, ACEC, Southern New England ITE throughout the year. In total, 56 Stage 1 submissions were received and 45 Stage 2 submissions were received in 2024. In 2025, we continue to make improvements to the process and the forms. Improvements include work with GPI on the development of a framework for systems analysis for closely spaced intersection systems and a qualitative safety analysis, since we have encountered numerous situations where a quantitative analysis is not possible, sometimes due to intersection type, one-way configuration of some legs, number of legs, etc. These 2 frameworks are currently under development. To date, in 2025, we've received 33 Stage 1 submissions and 32 Stage 2 submissions. You'll notice the number of submissions has decreased since 2023 because of the development of the applicability form, since projects are no longer unnecessarily going through the intersection control evaluation process. The applicability form was born in April of 23 as a way to take some of the interpretation and guesswork out of determining where ICE was required. If the evaluation is required, designers or on-call consultants can complete the Stage 1 of the evaluation. Stage 1 is the basic screening, followed by Stage 2, the initial assessment, and then in Stage 3, in rare cases, where the control is not clearly preferred after the completion of Stages 1 and 2. At project initiation, the project intake tool includes questions to determine if the intersection control evaluation is applicable to a project. If it is, then an applicability form is submitted for the project. ICE applicability is typically confirmed during PRC And ICE Stage 1 is due prior to the project scoping meeting to better inform design requirements. For MassDOT design projects, an on-call is used to accomplish this before the project designer is assigned. ICE Stage 2 needs to be approved prior to the over-the-shoulder, and occasionally we encounter projects where the cross-section is being evaluated, for instance, a road diet, and the OTS may include the discussion on the cross-section, and after that is ironed out, ICE would be completed, assuming the appropriate cross-section. Intersection control evaluation is intended to provide an apples-to-apples comparison of control strategies, so comparing multiple iterations of each control type is generally not the intent. First step in the process is to consider if the evaluation is applicable to a particular project. An applicability form should be completed for all projects that are part of the MassDOT advertising program and development projects that were specifically scoped for the intersection control evaluation, with the exception of projects that are municipally led on local roads, not using FHWA funds, or being designed or advertised through MassDOT. Projects that are funded through Chapter 90 or MassDOT grant programs on local roads, projects that have been granted a waiver by the state traffic engineer, MEPA projects that already have Section 61 findings in place, and permit projects. After it's determined that the intersection control evaluation is required for a project, each intersection within the project limits is evaluated to determine if the evaluation is required. Criteria requiring the evaluation for a particular intersection include creating a new intersection, adding a leg to an intersection, adding a left through channelized turn or bypass lane to an intersection, obviously changing the intersection control, but also when an intersection identifies as a high crash location. Exceptions to this include when the intersections have a minor street ADT of 1,000 vehicles per day or less, or intersections that have been granted a waiver by the state traffic engineer. So here's a quick look at our applicability form. On the top of the form, you can see the questions that should be answered to determine the applicability for the project as a whole. And then if the intersection control evaluation is applicable to the project, then step 2 would be completed, and that's where you can answer the questions for each of the individual intersections that are within the project limits. Stage 1 considers a wide range of control strategies, from two-way stop control and all-way stop control to signals, roundabouts, median U-turns, restricted crossing U-turns, jug handles, displaced left turns, continuous green Ts, and quadrant roadways. Stage 1 is used to rule out fatally flawed alternatives, including those that have operational or safety issues, do not work from a right-of-way or environmental perspective, do not meet the purpose and need of the project, or do not fit the local area context. If Stage 1 concludes with a single viable control strategy, then the intersection control evaluation is complete. If there is more than one viable control, then the intersection would advance to Stage 2. During Stage 1, fatal flaws are considered for control strategies. Right-of-way can be considered a fatal flaw if Article 97 is required for one alternative, but not others. It can also be a fatal flaw for municipal projects where the right-of-way process is not supported by the municipality, if the municipality would be the ones that are responsible for the right-of-way takings. Permitting obstacles that can be fatal flaws include the removal of 5 or more shade trees or business takings within an environmental justice community. In terms of project programming, fatal flaws can be identified if a particular control strategy does not align with the project needs, objective, or scope of the project, or requires right-of-way or permitting processes that would push the project schedule beyond the program timeline. Controls that are not in conformance with the MEPCD are also considered to be fatally flawed. For instance, if you have an unwarranted traffic signal, that's something that we would consider a fatal flaw. Our goal is to wrap up Stage 1 as efficiently as possible with the data that is available at the time. If, when starting Stage 2, a concept sketch is drafted that indicates a fatal flaw for right-of-way, then an abbreviated Stage 2 can be submitted, not requiring the full Stage 2 quantitative analysis. Similarly, if after count data is collected, it is determined that a signal is not warranted, that can also be used to justify a signal being fatally flawed, and an abbreviated Stage 2 could also be submitted in that sort of situation. Stage 2 is an initial assessment that is conducted to determine the control that would provide the long-term best value for a particular intersection. Stage 2 includes conceptual sketches of the intersection controls, And then based on those concepts, safety and operational analyses are performed, and the results are used to compute the societal costs for the control strategies. The safety analysis concludes with a predicted number of crashes for the intersection controls, and then the capacity analysis results, or the delay in seconds, are also used in stage 2. So stage 2 includes cost estimates and consideration of operating and maintenance costs for each control as well. All of these values are combined into the ICE tool to determine the net present value and then documented on the ICE form. In general, the control that has the lowest net present value would be the preferred intersection control. In many cases, due to the safety benefits and operations, a roundabout would generally have a lower net present value. However, there have been some cases where the traffic volumes are such that the signal ends up with a lower NPV due to operations, despite the safety benefits that the roundabout offers. If stage 2 concludes with a clearly preferred intersection control, then the evaluation is complete for the intersection. If multiple control strategies remain, then the intersection would advance to stage 3. Stage 3 is a detailed assessment that is only required if all of the initial assessment methods are exhausted. The detailed assessment may include a higher level of design to model impacts, more detailed traffic analysis or microsimulation, detailed cost estimates, and a deeper look into environmental impacts. On rare occasions, this detailed assessment is raised to the Office of the Chief Engineer for determination when there is a large difference in net present value, but there are some impacts that can only be described qualitatively. At the conclusion of stage 3, there will only be a single preferred control strategy and the ICE process will be complete. So far, MassDOT has reviewed nearly 300 projects in some aspect of intersection control evaluation since the rollout of the process. There are approximately 84 projects currently in process, 41 that have concluded at applicability, meaning that no intersection control evaluation was required. 31 projects concluded at stage 1, 53 projects concluded at stage 2, and 3 projects concluded at stage 3. Waivers were also granted for 41 projects, and the evaluation process was no longer required there. We have seen a variety of control outcomes from the evaluation process, and where it's required, signals remain the most frequent preferred intersection control by project. Roundabouts do make up a good portion of the control outcomes. The evaluation has even yielded some innovative intersection controls, including displaced left turn and a jug handle in different locations in the state. We've also seen a signal with some continuous green T elements come out of the process. To learn more about the different stages of the intersection control evaluation, you can visit the MassDOT Intersection Control Evaluation webpage to view training modules for all 3 stages, including some case studies for both stages 1 and 2. Here are some tips for municipalities. So be aware of your ability to take right-of-way and make that clear from the get-go. If it's an absolute no-go, you should communicate that early on. That can save a lot of time in the intersection control evaluation process. Also, double-check applicability, especially for legacy projects. As we've made improvements to the process, we've removed the requirement that any project that had some full depth reconstruction as part of the project triggered ICE. If your project started when the ICE process was still early on, so say maybe 2022 to 2023, revisiting the applicability form can be very helpful. Attend a scoping meeting for your project. The scoping meeting doubles as a comment resolution meeting for the ICE stage 1, and viable controls can be discussed in the meeting. Sometimes a systems analysis is recommended, for instance, for closely spaced intersections, instead of intersection control evaluation for each individual intersection within a project. Waivers and an abbreviated process are options, and these can be discussed in the scoping meetings as well. If you cannot attend the scoping meeting, have these discussions with the MassDOT program manager or project manager. And also have some realistic expectations for the timeline and funding if a project does need to go through the intersection control evaluation process. For municipal projects, you can see that the average ICE stage 1 is about 46 days, needing approximately 1 revision. 45% of projects have needed no revisions, and 58% of projects concluded after stage 1. For stage 2, that time frame is quite a bit longer, as you'll see. It's averaged about 181 days with about 1 revision. Only 17% of projects have needed no revisions, while half of the projects we have seen required more than one. All municipal projects have concluded after stage 2 at this point, meaning that there's been no municipal projects that have gone to stage 3. And for more information or questions about the intersection control evaluation process, feel free to visit our webpage or email us at the addresses on the screen. I do monitor the traffic safety analysis email inbox, so if you are messaging that, I will be the one who will get back to you. If you do have municipal scoping questions, Ben Mueller is your guy, and his email address is also here in the presentation. And that's all I have for you for today. I'm happy to take any questions.